Hello, APE students, and welcome to probably the weirdest lab I've ever had to do. If you are on your phone, I would pause this video and try and bring it up on the biggest screen that you can, because the first thing you're going to notice when you see this is that I'm sharing two screens at once. So on one side, you see the area where I'm actually going to do the lab. Hello. And then you also see on the bigger screen the data sheet that looks exactly like the data sheet that you guys are going to have to fill out as you move through. All right, so I'm going to make a copy of this so that when I mess it up, it doesn't mess up the ones that you guys are going to do. And what I recommend is that you guys, either in another tab, or you can pause and do it, or you can print it out and do it with me, but fill out this data table as we go through the lab. The data table looks a little daunting, but as we get through it, one of the things we'll see is that the numbers we need to put in it are pretty straightforward. So let's talk about the lab a little bit and then we'll get started. I don't want to make this video unnecessarily long. So essentially what we're going to do is we're going to look at predator-prey relationships, which is a pretty common topic of study for population ecologists. So if you're studying populations, predator-prey relationships are pretty important. They're a pretty significant contributor to increase or decrease in population changes. So first thing we got to see is that you see I have a little petri dish. We're going to pretend this is a field. Inside this petri dish you see are some tiny little mice. Now, of course, with this field of mice, it attracts predators like owls. And so in this simulation, our owl is going to be this spoon. So I know that beads don't look like mice, and I know that spoons don't look like owls, but this is public school, which means we have to use our imagination. So we have a field full of mice, and we have an owl. What we're going to do is we're going to go through here, and we're going to fill out this data table. But our ultimate goal is to take this data table and turn it into a graph. So you'll see on the third page, there's a much smaller data table, and this is actually what we're going to graph. And I'll talk about that at the end when we're ready for it. And hopefully, when we get a graph, what we'll find is a very clear pattern, a relationship that you can definitely see between predator populations and prey populations. So the first thing you should do, if your copy doesn't already have it, is jump down to Table 2. And the important piece of data here that we need are initial prey and initial predators, because at the end, those are the two rows that we're going to graph. So our ecosystem is going to start with 10 mice. It's going to start with 1 owl. A couple of rules about our ecosystem. Obviously, the owl is going to try and eat the mice. It's going to do that by me just passing the spoon randomly through the petri dish without looking. However many beads I scoop up is how many mice the owl eats. Our valley, or our meadow, or whatever we want to call it, can never fall below 10 mice. So right now there are 10 beads. If the owl manages to somehow eat all 10 before we start turn 2 or generation 2, I'll restock 10 mice. Our ecosystem can also never fall below 1 owl. Now the number of owls is going to be simulated by the number of times I scoop through. So for trial 1, I have 1 owl, I'll do 1 pass. Later on, I may have more than 1 owl, so if I had 2 owls, I would take 2 passes through. Mice don't have big nutrient requirements, so they're going to reproduce every single generation no matter what happens. Every single mouse that's alive is going to produce another mouse. And if you know anything about mice, they reproduce pretty quickly. That's not far off real life. Owls, on the other hand, have big nutrient requirements. An owl needs to catch mice in order to live. So an owl that doesn't catch any mice will die. In fact, an owl that doesn't catch at least 5 mice will not reproduce. So our owl can stay alive if it catches fewer than 5 mice, but it needs at least 5 to reproduce. For every 5 that it catches, it gets to have a baby. And that's how we're going to increase the number of owls that we have. Now, if we look at the data table real quick, we'll see generation, and underneath that we have how many mice were caught in the first generation, how many mice were caught in the second, as well as how many owl offspring each owl had. The number of owls, or the number of scoops we take, is going to be right here across the horizontal axis, up to 20. I do not think we'll ever have 20 owls, but we will see. And just so that we can hurry up, we'll get started, and pretty quickly you guys will catch on to how we're supposed to be doing this and then how it's going to go. So if you don't understand yet, once we get into it, I think you'll be able to see pretty easily what's going on. So I'm going to take my owl. I'm not going to pay attention to what I'm doing, and I'm going to scoop, and I see that this owl scooped 0 mice randomly. So for mice caught, I'm actually going to put 0. For owl offspring, I'm going to type a 0. I'm going to scroll down to table 2. My initial prey was 10. Prey captured was 0. Prey survivors, 10. Predator survivors, none. Predator offspring, none. Now, before I start the second pass, and this is the confusing part that people need to do ahead of time, I have to go ahead and calculate initial prey and initial predators for the next round before I start. Now, remember we said one of our rules of our meadow or our valley is that each mouse that lives gets to reproduce. So we had 10 mice. Each one of them is going to make another one. So I'm going to go ahead and add 10 more mice to our ecosystem. And 10. So we have 10 mice in our ecosystem that we've just added. So that brings our initial prey up to 20. Now, initial predators, we would be tempted to fill this out with 0, but we said that we can never have less than 1 owl. So it's still going to be 1. And then we're ready to jump up to this data table. So mice caught, generation 2. So be careful not to write your answer here. This would be if generation 1 had a second owl, but it didn't, so we're not going to use those rows or columns. We're going to jump down here to row 3 where it says mice caught. We only have 1 owl, so again, without looking, I'm just going to do a complete pass here. I see that my owl caught 4 mice. So 4 mice are dead. Now I'm going to use the lid of this petri dish as our little mouse heaven. So how many mice were caught? 4. How many owl offspring? This owl caught mice, so it got to live, but it didn't have 5, which means it doesn't get to reproduce. So still 0 owl offspring. Jump down to table 2. Prey captured, 4. Prey survivors, 16. Predator survivors, 1. Predator offspring, 0. So for our initial prey, we see that 16 survived, which means I add 16 more. Which means my initial prey, we're up to 32. That's 16 doubled. Initial predators, still 1. Our owl has not gotten to reproduce yet. And now we're ready to start with generation 3. So we found mice caught 3, and we're going to do the exact same thing. We got 1 pass through, not looking, we scoop, and we see this owl did pretty well for himself. 2, 4, 6, 7 mice. So mice caught, 7. Number of owl offspring, 1. It caught at least 5, so it survives, and it gets to make 1 baby. So now we scroll down. Prey captured, we can say 7. Prey survivors, 25. Predator survivors, 1. Predator offspring, 1. Dump these guys in mice heaven. And now initial prey, we have 25 doubled, so we're up to 50. For initial predators, we have 1 surviving owl plus 1 baby. So now we have 2 owls. So I need to add 25 more beads, aka mice. 5. We see our mouse population is starting to grow pretty significantly. Jump back up to the first table, and we've got mice caught in the 4th generation. We're going to do exactly what we've been doing. So I'm going to scoop. I see my first owl caught quite a few. We got 2, 4, 6, 8, 10, 12. So mice caught 12. Now we have 2 owls, so we're actually going to spread these out again, and we're going to do one more pass. We see this owl also did quite well for himself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that owl caught 16. So first owl caught 12. It caught 5, so it had 1 offspring, and then it caught 5 more, so it's actually going to have 2 offspring. The second owl managed to catch 16 mice, so it's going to have a total of 3 offspring. Jump down to table 2. So for prey captured, we're going to add together the 12 and the 16. Should give us 28 prey captured. Of course, if we have 28 prey captured, we're going to have 22 that weren't. Predator survivors, both owls survived. Owl 1 had 2 babies, owl 2 had 3 babies, so we have now 5 baby owls. And we're ready for our initial numbers for generation 5. So 22 doubled is 44, which means I need to add 22 more bees. And then for initial predators, our 2 owls survived, plus the 5 babies gives us 7 total owls that are alive. So we scroll up, we go to generation 5, and we know we're going to have to do 7 passes. So pass 1. Our owl got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So owl 1, 11. Owl 2, spread them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Consistent. Owl 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Owl 4. Nothing. Owl 5. 4. Owl 6. Nothing. And then owl 7. Nothing. Okay. So the reason I'm completely missing these beads sometimes is because I don't look and I just pass it through randomly. Because out in nature, not every single owl gets enough food. One of the mistakes people make very commonly when we do this lab in class is that they try and see how many they can scoop in one go, but that gives us some pretty terrible data. So we want it to be as random as possible. So let's go through and do our owl offspring. We see owl 1 will have 2, owl 2 will have 2, owl 3 will have 2. The other owls don't get to have any. And then we see 1, 2, 3, 4 of those owls survived. So let's go fill out our table. So for prey captured, we have 11 and 11 and 13 and 4. So 39 of our prey were captured. Oh, and he fell out. So that brings us to 44, which is correct. Prey survivors, 1, 2, 3, 4, that gives us 5. Predator survivors, now of our 7 total owls, we see that 1, 2, 3, 4 survived. And for babies made, we see we have 2, 4, 6 babies. So we're up to 10 owls. Of course, these 5 mice get to reproduce. Which brings our initial prey population up to a whopping 10. And our predators, we got 4 that survived, we got 6 babies, it is also up to 10. And let's jump up and do generation 6. So we're going to go through 10 swipes. 1, got 1. 2, got 1. 3, got none, that doesn't count. Owl number 4, got 1. Owl 5, got 1. Owl 6, got 0. 7, got 2. Owl 8, got 2. Owl 9, 0. And finally, owl 10, 0. So owl offspring will have zeros across the board, and nobody got 5. Prey captured was 8, which left us 2. Predator survivors, we have 1, 2, 3, 4, 5, 6 owls that survived. Owl offspring is none. Now we would say that these mice reproduce and they would give us 2 more mice, but the rules we set forward were our habitat for our mice can't fall below 10. So I'm going to go ahead and add 8 more of these to bring us up to our 10 that's our minimum. There's 10. So initial prey back up to 10. Initial predators is going to stay 6. Let's do generation 7. Spread these guys out. We've got 6 owls to feed here. Owl 1 got nothing. Owl 2 got nothing. Owl 3, 1, 2, 3, 4, 5. Owl 3 got 6. Owl 4 got nothing. Lost a mouse. Owl 5 got nothing. And owl 6 got nothing. So for offspring, none of the owls except for owl 3 had any babies. And we can jump down here. How many of our mice were captured? 6. Prey survivors is 4. Predator survivors was just 1, and then it had 1 offspring. So we're going to start the next generation once again with 10, because 4 plus 4 is 8, but we can't go below 10. And then our initial predator is going to be 2. And we can do generation 8. So we have 10 mice, 2 owls. Let me get these kind of spread out. So owl number 1, 5. Owl number 2, nothing. Owl 1 has a baby. Owl 2 dies and has nothing. Prey captured is 5. Prey survivors is 5, which means our initial is going to be 10. Prey survivors 1, babies 1, still at 2 owls. Jump up and do 9. There's 10. And once again, we have 2 owls. Owl 1, 3. Owl 2, 1. No babies, so we keep 2 owls. Prey captured is 4. Prey survivor is 6, which means we're going to start with 12. Initial predators, I put in the wrong spot, but both of them survived, but neither of them had any offspring. means we still have 2 predators. So let's add 6 beads and let's do generation 10. All right. Gen 10. Owl 1, 3. Owl 2, nothing. So no babies. We captured 3. That means we have 9 left, which means we're going to start the next generation with 18 mice. For predator survivors, just 1. No kids. We're going to start the next generation with 1 owl. Now, to keep this video from being absurdly long, I think you guys kind of get the hang of how I'm doing this, where my numbers are coming from. So I'm going to stop the video here. I'm going to keep doing the lab, and I will post my full data sheet onto Google Classroom, and you guys will just need to make sure you copy it on the data sheet that you're going to turn in. There are questions at the end to do. You do have to make a graph. You can do that by hand and email or attach a picture, or you can do it on Microsoft Excel and just copy and paste it onto your lab sheet itself. So however you choose to do it, that is entirely up to you. And let me know if you have any questions. Thanks for watching.